मैंने डेस्कटॉप को देखा नेटवर्क के लिए मोबाइल देखो कॉस्टली मोबाइल का ऑफ के लिए आपसे क्या बोल रहे हो ये हमारा 50% मार्क मिला because it was story मस्त है ना सब एक हेलीकॉप्टर पूरा नहीं है सीधा खाली एक आई हो गया ये ड्राइवर को बस कुछ ले लेता एंड मुझे इसको छोड़ देता नहीं और मैंने सामने भेजी और भाई बंद ठीक है एंकर है फर्स्ट टाइम बोला नहीं मला ते ब्युटी विथ ब्रेन्स आणि हँडसमनेस असतात म्हणजे मी सांगता हां यूज करतात ये बेटा चांगली विचार वो बड़ा हमारा नहीं मस्त विचार ऍपल आणि
शायद ये लॉक था तो कैमरा पे आ गया
एक बार एक वीडियो में तुम्हारा फॉर्म डाला है तो वो तुमने करना बर्थडे के दिन
हाँ वही
क्या क्या
मेरा वही है
15 मिनट का ब्रेक तो ऐसे खत्म हो जाता है जाओ आओ और 15 मिनट खत्म Is everybody in? Some crisis? No? क्या हो गया? Is there anything I can help? Help you or नहीं? Shall we? या और 1-2 मिनट चाहिए 5 मिनट ब्रेक कितना भी लो कम ही होने वाला है ठीक है नाउ इट इज एंडिंग सो रिलैक्स अभी हम आई थिंक फ्रॉम जून विल गो बैक टू आवर ओल्ड स्टाइल 2 hours वाला दैट इज मच मोर रिलैक्सिंग बट इज इट gainful which did you find more gainful this method this one because you get a lot of content okay chalo इसमें क्या करना है so everybody is familiar how to draw the ray diagram for prism it's just one triangle then this ray is parallel to the base ठीक है you have to draw 2 normals so pay attention to the sequence the triangle the normal at midpoint at both the faces right so this is the first refracting surface this is the second refracting surface and you have, let's call this as PQRS, right? And this is Q. What name should I give? O and T. Okay. So have we labeled everything? Okay. So now I'm not labeling anything now. You know what is PQ? Incident ray. What is QR? Refracted ray. What is RS? Emergent ray. Okay, so this is a universal language, right? Incident ray, refracted ray in the medium, and then when it is coming out, it is emergent ray. Okay. This is our normal NM and MM dash. Now, so we have to find a relation between the incident ray, the emergent ray, the angle of the prism and angle of deviation. Yeah, what is this? Where? So you should know this. I is angle of incidence. A is angle of emergence. A is angle of the prism. So which prism we are using? Equilateral prism. This is the angle of the prism. Okay, 60 degree. Everywhere 60. Okay, so this angle is same. So this is an equilateral prism, right? Then we have angle of deviation. What is angle of deviation? Deviation. What is the angle of deviation? It is the angle between emergent ray and incident ray. Always, right? I have explained it in the first lecture. What is angle of deviation? Angle between emergent ray and incident ray direction. angle between emergent ray and incident ray direction. Incident ray direction. What was the angle of deviation in case of glass prism? Rectangular glass. Was there any deviation? No deviation, because the rays were parallel, right? Here is the deviation. So when the emergent rays in the different direction, incident rays in the different direction. Now for you missed that first class, right? What is refraction of light? Refraction of light is whenever light travels from one transparent medium to the other transparent medium, the path of light changes in the second medium due to the change of speed of light in different medium. So light travels with different speed in different medium, right? So air is the medium where light travels with fastest speed. And what is the speed? 3 into 10 raised to 8 meter per second. In all other mediums, its speed gets slowed down. So glass is a denser medium than air, so speed of light will be less. So whenever the speed reduces, its direction goes towards the normal. Okay? And there is a law. What is the law? Whenever you take the ratio of sine of I and sine of R, it is always constant for a given pair of medium. That constant is called refractive index, which is mu. So if this is G, this is glass, right? And if this is air, okay, these are the two medium. So we will write Snell's law as sine of I upon sine of R at this point, at Q, is equal to refractive index of glass with respect to air. And this is always constant for any angle. Suppose I take a different angle now. So when I take, then whatever is the refraction angle I get, if I take their ratio, that also will be same. So that constant is called refractive index. Got it? So likewise, this is a glass air medium. So glass air will be 1 by like this. So it is the second medium which comes first. Here when the ray was entering, what is the second medium? Glass. Okay, first medium is air. Now when it is coming out, then what is it? Air, glass. So relation between this and this is always reciprocal. बस इतना ही है, ठीक है? बाकी तुम पढ़ोगे तो समझ आ जाएगा. Okay, so this is a law. जो एक additional law आता है in case of refraction of light. ठीक है? So this was only for you. I'm just erasing it. This is not part over here. Okay, now. So we have to derive the relation between I, E, A and delta. Right? This is called delta. Small delta. What is the big delta? Triangle. Okay, big delta. So how do we derive the relation? Is there any other black marker? So now consider quadrilateral AQMR, right? So what is the sum of angle A and M? Right? See, what is this sum? Normal 90. The total is 360. So these two angles should total 180. Correct? A plus angle A plus angle M. Do you understand this? Right? So sum of all the angles of a quadrilateral is 360, right? But this and this, like when I say this and this, I mean this. This is one angle, and this is another angle. These are 90. So these two should add to 180. Now, but what is M? Angle M is equal to, from this triangle, 180 minus 2R. Correct? Isn't it? From triangle QMR. We'll apply angle sum property, right? So what is angle M? This angle plus this angle plus this angle is 180, right? Okay, so 180 minus 2R will be this angle. You just okay. Is this clear? So this is 1. कोई था क्या? Okay. So what is then therefore A plus 180 minus 2R? 180 degree, 180 degree minus 2R. What will happen? Okay, this is equal to भूख लगा लगता है 180 degree, right? So by 2 in 1, correct? अब क्या हो गया? So this 180 cancelled. Therefore, angle A is equal to 2R. Right? Angle A is equal to 2R. Okay, actually. Now, what is this angle? This angle is equal to I minus R. And this angle is equal to E minus R. Right? Okay. So we are writing this as equation 3. Now, by exterior angle theorem, angle of deviation is equal to sum of equal and opposite angles. Sum of opposite angles. So this is I minus R plus E minus R. You agree? What is angle of deviation? This is the exterior angle. Now exterior angle is equal to sum of angles of interior opposite angle, right? Okay. This is from triangle OQR. Do you agree? So deviation must be equal to sum of interior opposite angles. Okay. Okay. Now, so simplify. Therefore, deviation is equal to I plus E minus 2R. But what is 2R? A. So I am just removing the angle, I am just writing A now. Okay. So by 3 in 4, what do we get? Deviation is equal to I plus E minus A. Or we have I plus E is equal to delta plus A. This is the okay. We set out to derive this relation. So relation between. So whenever there is a refraction of light through prism, this relation will be obeyed, right? Now there is a case of minimum deviation. Have you written this part? You have not written anything? Okay. So चलो ठीक है, यहाँ तक लिख लो फिर. Quad is quadrilateral. Okay, this is I have written short form, quadrilateral. What was the crisis?
Sir, it's video went viral.
Which video? Huh?
Birthday.
Acha. You made it viral yourself?
Sir,
Or?
I'm not there.
Sir, in that video, he has a very funny face.
Funny face.
Yeah, we took home and covered his full face with it. We took home and put it on his face, full face.
Oh,
Acha.
On his
This-
birthday.
It is a mischief created by your friends.
yes, sir, I'm
Yeah.
working.
And that video was recorded secretly.
It has went viral amongst the same community, right?
Yes.
I think so.
So फिर ठीक है ना? Friends, yeah. That's why we have birthday parties. You'll start earning a lot of money now since the video has gone viral.
Sir, I'm not there.
Acha, you don't.
I don't.
I created a YouTube video lecture. It was only seen by 10 people. Now, all 10 were family members. 5 times I only saw it. So, I have to learn how to go viral. So don't stop studying for income due to YouTube videos. It's a crazy thing. It may or it may not. So keep studying, okay? Yeah. Don't be influenced by these YouTubers. You become a YouTuber after finishing your studies. It's not a substitute for education. So I'm sure you might be having some favorite YouTubers like what? Curly Tails. Huh? And flying beach, anybody? Flying beach, Mumbai ka Nikhil.
Vlogs, yes.
Okay, so we are all the same, okay? We share same interests.
International vlogs are really good.
Internet, so we have so many Indian bloggers now. Like there's one Traveling Desi. I keep watching his videos. Anybody has seen Traveling Desi?
No.
So he is an Indian with Canadian wife, and he travels the world and makes beautiful videos. Sorry. Yeah. So let the joke travel everywhere, right? Don't limit it to yourself.
Flying fish.
Huh?
I was flying fish.
Flying beast, huh? Traveling Desi you should watch. He makes travel videos all across the globe. So I have seen US, Canada through him. He drives in a motorhome. Every street of Canada and US you can discover. Not only that, Latin America, all is traveled everywhere. So last series was about UK. And he goes to places where media does not go. So you can go really till the village of UK and see how it is. And he talks about foreign visa, student visa. So it will be helpful to
He's
decide.
living there.
Huh?
He's living there.
He keeps traveling, he is very rich. So his income is so high that it doesn't matter. So he's a globetrotter. So he has a Canadian wife, of course, so no issues. Yeah. But that she lives in Canada, but she's basically French national, French origin. So there are many. So she's from Quebec region, Ottawa, like east of Canada, eastern Canada. So if you see his videos, you almost are there. It's such nicely created. Which channel I said? Traveling Desi. So you cannot forget traveling Desi. We are Desi. We are called Desi, right?
Yeah.
Outside. So whether it is a Sri Lankan, Bangladeshi, Indian, Pakistan. So these guys don't have identity. These Pakis, Sri Lankans, they're all Indians. For West, they're all Indians. Okay. So and they also try to be behind the Indian name, because if they know he's Pakistani, the respect goes down immediately. So when I was working in Dubai, right? So these Kuwaitis, which is a Muslim country, they used to send the Pakistanis back, never allow them to enter in their country. So our office colleagues who were Pakistanis, they were not allowed to enter Kuwait. Can you believe it? And we holding Indian passport can travel anywhere. So that's when I realized I'm from a powerful country. So Indian passport has a lot of value. This you realize when you go out. So much gyan I gave you along with physics for free. Any study abroad aspirants in the room? बाहर जाके पढ़ना है? 1, 2. Which is the country looking for? US?
US.
Canada? US? Switzerland. Singapore? No? Singapore?
Philadelphia.
Philadelphia, USA. Good.
My relatives are there, so it's easy to go.
East US, East Coast. This side. Completed? सोच रहा हूँ मैं बस ऐसे ही टपके मारूंगी. Can I erase this side?
Yes.
Okay. Sometimes gossiping, relaxes. Sometimes. Okay, now, minimum deviation. Experimental observation. Of variation of with respect to angle of incidence. Okay, so this is angle of deviation, angle of so what is the observation? So you have written till. So write with awareness, like what we are doing. If you need any explanation how we have done it, have you understood what is written here? You have to understand and remember later on. So this is equation 5, let us say. Not that minimum deviation the refracted ray QR is parallel to this of the prism.
So what is WRT?
With respect to. So I am telling this in every class, right? What is WRT? It means with respect to. Somebody asked me from this side last time. Should I explain the experimental observation? This is U, but not the full. Yes. Cup with broken one side, U. Like
It's
that.
not full.
It's not full. See the diagram. See the diagram in the book. So let me explain this first. So when do you get this line parallel to the base? Only at minimum deviation. Now this is an experimental observation. So pay attention here, girls. When I'm explaining, pay attention. When you draw the graph of angle of deviation versus angle of incidence, so क्या होता है? You start with angle of incidence 0, right? So when the angle of incidence is 0, like when the light is along the normal, that time the deviation is, what is the deviation? 0, right? So is it 0 or too high? Deviation is too high, not 0, right? It's indeterminable. It's infinite. You cannot determine it. But as the angle of incidence increases, the deviation reduces. At a certain value of angle of incidence, deviation becomes minimum. Now these are, you can record these angles. Okay? So when you are increasing the angle of incidence, like when you are going like this, okay, then what is happening to the deviation? This deviation is reducing, right? This ray is first, so this deviation is reducing, but at minimum deviation, at certain angle it will reach minimum deviation. Beyond that, the deviation again begins to increase. This is the graph. So when the angle is less, deviation is high. When the angle increases, deviation decreases till a certain value of angle of incidence. Increase the angle of incidence further, deviation increases again. Okay, this is experimental observation. Now this is a specific case. At minimum deviation, what do we get? We get these things. This becomes parallel to the base, and angle of incidence become equal to angle of. So this is the case for minimum deviation. This ray diagram. Okay, and this is what will be asked you. You have to draw the ray diagram for minimum deviation. So for minimum deviation, I is equal to E. So this becomes I plus I, and this angle becomes delta minimum. Okay, that's it. The rest is simplification. Okay? Okay, finish writing. So with this we have completed
Delta minimum increases when the angle of incidence.
delta minimum cannot increase. Delta minimum is just one value.
So if the incidence.
Angle of incidence increases further, right? Then delta begins to increase.
Okay.
That's why it is touching the bottom, which is delta minimum. Now you further increase I.
Delta minimum will increase.
Delta will increase.
Delta.
Delta minimum is just one value, for which the refracted ray is parallel to the base. It's only for this situation I will be equal to E. So you have to make this diagram parallel. For me, I think it has gone little long, but this is parallel. Okay. Most of you have drawn parallel, right? Have you drawn parallel? Yes. तुमने बिल्कुल कॉपी किया है. हाँ, this is parallel. Arrow. See the diagram in the book. Textbook में ये है तुम्हारे पास. Parallel होना चाहिए एकदम. This is parallel to the base. ये जो रे है ना, this ray should be parallel. This is base, parallel. Volume में देखो, ये textbook में तुम्हारा है. You're ready to draw the diagram. इसलिए डायग्राम ड्रॉ नहीं किया था क्यों?
सर मैंने पहले लिख दिया.
अच्छा ठीक है. क्यों मेरा डायग्राम? हाँ, यहाँ पे एरो बनाओ. एरो. अरे यहाँ पे भी डिफरेंट रीजन में एरो होना चाहिए. ठीक है? Then the other thing is, where is your minimum? This is minimum. Huh? Bottom is here. यहाँ से कैसे minimum लेंगे? This is minimum. This is where your angle of incidence will be equal to angle of. ठीक है, ये point है. ये minimum नहीं, इसको मिटा दो. हाँ जी. हाँ, ये परफेक्ट. डिविएशन एंगल का उसको पीछे लो. ये डिविएशन एंगल. अगर डिविएशन नहीं तो फिर रिलेशन किसका है ना? Do not. So there are four angles: I, E, delta, and A. Four angles are there. चारों दिखने चाहिए तुम्हारे डायग्राम में. I minus R कहाँ से आया, ये सबको समझा? How did we get I minus R? This is I. So full angle vertical opposite is I. I minus R. तब ये I minus R होगा. ये पूरा पीछे किया तो this is angle E. E minus R करोगे, E में से R subtract करोगे तो E minus R मिलेगा. Okay? So do it with full understanding. ये सब एंगल लिखो. डायग्राम थोड़ा बड़ा बनाओ. In optics, it is all about ray diagrams. ठीक है? Diagram अच्छे से बनाओ. Practice करोगे तो easy हो जाएगा. At minimum deviation, the refracted ray QR is parallel to base of the prism. Base, BC. Base क्या है? BC, right? Is there anybody who is struggling with the diagram? Now you know parallel. No, first देखो ये गलती क्या किया? When you start ना weight point में normal होगा. अभी तुम्हारा क्या होगा ये normal जो extend करोगे ना सीधे नीचे पड़ेगा. but ठीक है बन जाएगा. ठीक है mid point में रखना है normal. हमने भी ये तो mid point में नहीं रखा नीचे. Normal should be at the midpoint, है ना? तुम्हारा भी जो रे है पैरेलल नहीं है बेस को, ठीक है? करेक्ट. वो आएगा ही नहीं है सर. तुम या तो पूरा डायग्राम फिर से बनाना पड़ेगा, ठीक है? तो घर जाके ठीक करना. हाँ दिस इज करेक्ट. देखो सबसे पहले क्या करना है, यहाँ पे है, ठीक है? यहाँ बीच में नॉर्मल बनाओ, दोनों का सेंटर मार्क करो, नॉर्मल. देन रे, देन ये क्या डायरेक्शन दिया है? यहाँ से ऐसे जा रहे बाहर आएगा. तो इसको वही करेंगे, ठीक है? अभी एंगल ऑफ डेविएशन बाकी सब बना है. डेविएशन एंगल लिखा नहीं. तुमने फॉर्मूले में जितने भी एंगल मेंशन किए वो सारे लिखने चाहिए डायग्राम में, ठीक है? तो ये जितना है ना उतना ही ये बैठ होना चाहिए. तुम्हें सिमेट्रिक दिखना चाहिए डायग्राम, ठीक है? यहाँ से ये जितना दूर है, यहाँ से ये इतने दूर रहना चाहिए. ठीक है? Yes. Earlier it was. Right. No, this is why this is going away. This should be. This ray should have been this.
This much.
Yeah. You have shown extra deviation. The dotted should have been here, right? Along the direction of incidence. You have done an excellent thing. Show me. How you are not getting? See, this is incidence. Everybody come here. See what mistakes people do. देखो ये angle of incidence है, ठीक है? So this should have been straight. ये bend कैसे हो गया? This is straight in the direction of incidence. Am I bending my ray here? This is going straight. Change कैसे हो रहा है? ठीक है, अभी घर में जाके correct करना.
So I should just change the incident ray, right?
Yeah, for you, then it will be. No, incident ray was correct. The inside the prism.
And after update.
अच्छा ठीक है, हाँ, okay. You want to change the
incident rays are just extended.
extended backward. Okay, fine. Yeah, that's a intelligent thinking. Chalo, good. ठीक है, so shall I proceed? Next topic is about critical angle. Okay, next is critical angle. Critical angle. What is critical angle? So critical angle is represented with this symbol IC or capital C. Okay. Now I want everybody's full attention. Okay. Now this is a different concept. So far what we had seen, our light is traveling from rarer medium to denser medium. Air से glass में जा रहा है. Now what is critical angle? ये कहाँ पे apply होता है? When a ray of light travels from denser medium to rarer, okay? From denser to rarer medium. Right. The angle of incidence in the denser medium for which the angle of refraction in the rarer medium becomes 90 degree. The angle of incidence in the laser for which the angle of incidence is called critical angle of the medium. So read it and see if it makes sense to you. Right. Okay, so what is happening at IC? At IC, the angle of refraction is 90 degree. Understood? So we have seen cases where it is gone away from the normal, but when I go on increasing the angle of incidence, angle of refraction is always more. So for some angle of incidence, the refracted ray will be parallel to the refracting surface. Correct? So this angle of incidence for which this happens, when a ray of light travels from denser to rarer medium, now this is our glass medium, this is air medium, right? The angle of incidence in the denser medium, for which the angle of refraction in the rarer medium, right, becomes 90 degree. Okay, is called critical angle of the medium. So what is critical angle of the medium? The angle of incidence in the denser medium, for which the angle of refraction in the rarer medium becomes 90 degree. So this is the critical angle. Understood? So by Snell's law, what is the relation? Oh, लिख रहा था. Point. Sorry? क्या हो गया भाई? Everything okay? Okay. So applying Snell's law at O. बताओ, O पे Snell's law लगाएंगे तो what will we get? So what is the refracting medium? Air or glass? Air. So how will we write? Applying Snell's law at O, what is sine of Ic upon sine of 90? Okay, this is equal to air with respect to glass, correct? When we apply Snell's law at O, sine of Ic, what is the angle of incidence? Ic upon sine of refraction should be equal to refractive index of the second medium, that is air, with respect to first medium, which is glass. This is clear? Now, therefore, sine of Ic is equal to, what is it? Now, if I compare, I can write this as glass versus air, because there is a reciprocal. I change the medium, right? Now, critical angle is in the medium glass. So, how do I compare critical angle with its medium, right? So, how do you characterize the medium with its refractive index? So, I will take the reciprocal, or I write sine of Ic is equal to 1 by refractive index of the medium. When the first medium is A or air, we don't write the medium. So this is called absolute refractive index of the glass. So this is the relation between the refractive index of the medium and its critical angle. Got it? So generally we know what is the refractive index of the medium. So then with this relation we can find its critical angle. Right? So generally for glass, critical angle is roughly 42 degree. Okay, for diamond, can you see the table in your book? Critical angle is equal to 24 degree. Likewise, you have critical angle for various medium. Because refractive index of various mediums are known, right? You can calculate refractive index by the ratio of sin I by sin I. तो glass का refractive index होता है 1.5. So 1 divided by 1.5 is 10 by 15, मतलब 2 by 3. So I is equal to sin inverse 2 by 3. तो sin का table होता है, जैसे log table होता है, वैसे sin का table होता है. तो from sin table we can find IC. Got it? How to calculate critical angle? If you know the refractive index of any substance, इसका critical angle हम निकालो. समझ आया? लिख लो. थोड़ा टाइम लगेगा ये समझने के लिए. तो लिख लो. नहीं समझ रहा तो पूछो. ये देखो, there is a table like this, critical angle for some substances. Water का 49 डिग्री है, glass का 42 है, diamond का 24 या 25 डिग्री है, 24 और 25 डिग्री given in your book. Selena, so we have discussed critical angle and found the relation of critical angle with the refractive index of the medium. So factors affecting critical angle. So it is 5 more minutes after before break, right? When is the break?
No way.
No break?
Direct no.
Acha, okay. When is that? 2:15. No break. Oh, it's 2:15. No, it's 1:45. Yeah. Understood what is critical angle? So now we'll factors affecting critical angle. Therefore, so critical angle depends on the refractive index of the medium. So whatever will affect the refractive index, the same thing will affect critical angle. So what affects refractive index? What are the factors which affect refractive index?
Optical density.
Yes. Temperature, color, right? So what happens if the wavelength of light increases? Then the refractive index decreases. That means the critical angle increases. Okay. Wherever the refractive index increase, the critical angle will decrease. Is that clear? So what happens with temperature? The refractive index decreases, right? So since Ic is inversely proportional to refractive index of the medium, I'm just writing mu. Okay, because with absolute refractive index you don't write anything. You just write the medium for which you are discussing critical angle. Therefore, with rise in temperature, mu decreases, hence Ic increases. Right, so this is the first case. With rise in temperature, the critical angle rises or increases. With increase in wavelength, of light, what happens? Mu decreases. Hence, critical angle increases. So there is a mistake in the note, correct it, right? In volume, it says with increase in wavelength, critical angle decreases, it is written. Okay? So, where is it? Page 60. So wavelength, as wavelength increases, critical angle increases, you write. What is given is decreases. Have you corrected it? Page 60, the first line, factors affecting. Yeah, factors affecting.
Critical angle increases.
It should be increases, not decreases. So be careful, okay? Some information like somewhere there is typographical error, sometimes where there is an inverse relation, we made a mistake in writing. So always rely on the book information. Okay? Yeah.
Sir?
Yes.
Sir, that is you. That is you.
Yes, that is
That is what?
you. 1 upon you.
Yeah, 1 upon mu. Meow wala mu hai. It is pronounced as mu. और वो है क्या? U नहीं है. U is this. लेकिन ये क्या है? इसमें इधर में खींचा हुआ है ऐसा. ठीक है? तो U खाली without this tail. So it has. You don't have two tails, right? Shall we call it tail? Trunk and a tail. Okay, so next is total internal reflection. Let's understand that. We'll draw it here. Total internal How big is the chapter? Or chapter is big, right? Still. So we are reaching the end of it. So there you go. So understand this diagram carefully. We have a denser medium. Okay, so this is our denser medium, which is glass. Right? Now there is a source of light here. There is a light source. Now two rays, right? One along the normal. So the light ray which is incident along the normal comes out without deviation, okay? Straight. Now consider some points here. 1, 2, 3. Okay. So draw 3 normals. Let's say these are the 4 points. So you have A, you have B, C, and D. So from S to A, it is along the normal, so it will pass off undeviated, right? So at B, let us say this is incident at some angle of incidence, I1. So it will suffer refraction, like this. Let us say we are calling angle of refraction R1. Okay. Now here, let us say it is incident at critical angle. Here it is incident at critical angle. What is the angle of refraction here? 90. This is 90. So it will be parallel to the surface. It will be parallel to the surface but in air only. Okay. So whenever the angle of incidence, right, increases, the angle of refraction goes on increasing. So when we go on increasing for some angle of incidence, the angle of refraction becomes 90 degree. Now what happens when we increase the angle of incidence beyond angle of critical angle? Now we are increasing the angle of incidence bigger than critical angle. So now I is greater than IC. So it will be greater than 90. So when it is greater than 90, then it is reflected internally. Okay? So now it will be reflected internally. Now the light is reflected in the same medium. Whenever the angle of incidence in the greater medium is greater than the critical angle, the light suffers what is called as total internal reflection. Got it? So this is the phenomena of total internal reflection. So what are the conditions? So what are the conditions for total internal reflection? So conditions for total internal reflection is very important. Conditions for total internal reflection. So I am writing TIR. Okay, total internal reflection. So what is the first condition? The ray should travel from denser medium to rarer medium. So this is the denser medium, this is rarer medium. tensor. The first condition is ray should travel from denser to rarer medium. Okay, second, what is the second case? The angle of incidence in the denser medium should be greater than critical angle. Only then, right? So TIR is here, not outside. Outside में तो refraction होता है, ठीक है? So TIR is in the same medium. The angle of incidence in the denser medium should be greater than the critical angle. Makes sense? So whenever you have a question on total internal reflection, this is how you will address it. For the benefit of, अरे रेड लाइट तो दिखती नहीं है बिल्कुल. So the lights outside light, glaring due to outside light. Thus, so that brings the last topic of the chapter. No, I don't know. Hello. Manya diagram. That's not. This is a normal, huh? Yes, everybody got the diagram right. Next is applications of so deviation by 90. Too many diagrams, huh? Still some more. So last 15 minutes, some more diagrams.
More diagrams are that. Today, science, no.
Why? Everybody has reached the limit?
Yes.
Oh. So at least understand you can draw the diagrams at home. I'll draw the diagram and explain. And I'll show you where the diagrams are in the book. So till here is learning, okay? Concept. How is the application? Done?
Yes.
Yes, no, yes. How many no? Still? Raise your hands. One. Okay, fast.
Yeah.
in the textbook diagram, okay, they have shown the partial reflection. Don't show that. Okay, there is partial reflection also happening. I have not shown the partial reflection, only the refraction. Got it? So don't get confused by the textbook diagram. We have shown only the refraction and total internal reflection. Don't show in the diagram, okay? So see, like here also, this is reflected ray, partially reflected ray. This also, but this is TI. Okay. All right. Can I? Up they go. We are going to learn the application of total internal reflection. The first is deviation of the ray by 90 degree. So we will use which kind of prism now? A prism with two angle 45 degree, one angle 90 degree. Earlier we saw prism of all 60 degree. Okay. The ray refraction of ray of light through prism, that prism was equilateral prism. But now we are going to see a right angle prism like this. So one of the angle is 90 degree and this is 45. Okay. Now I am saying the deviation of the ray by 90 degrees. So at this space A, B, C, let us say the ray is incident here. So it is incident along the normal. How will it enter inside? Will it deviate? No. So it will hit straight. Okay. Now what is the angle of incidence here? What is the angle of incidence? So this is 90. This should be 45. Correct? Now when you draw the normal, are you listening to me? What is the angle of incidence? If this is 45, this full thing is 90, so this should be 45. Right? So angle of incidence is 45. Is it greater than the critical angle for glass? What is the critical angle of glass? 42 degree. And what is this? 45. Is 45 greater than 42?
Yeah.
So what should happen? Refraction or total internal reflection? Total internal reflection. So this ray will not go out. It will suffer reflection. So incidence is 45. So reflection also should be 45. Correct? So when the reflection is 45, it will go straight. Because this also has to be 45. Then this is 45, 45, 45, 90. So this will come out like this. Okay. So this is your emergent ray. This is your incident ray. What is the angle between incident and emergent? 90 degree. Okay, so this is deviation by 90 degree. So likewise, if you take one more ray, this is same. So you will actually get an output like this. Right? Same thing. So where do you use this feature? Where is it used? Periscope. Right? Use in periscope. You can use it, but at a different orientation.
It's like four mirrors together.
Yeah. So periscope. So what is periscope? Like you have. So why are we using prism now instead of mirror? You can use like this. Okay, so you can use it like this. So this will go like this, right? So periscope, why are we using prism for reflection? Because it is total internal reflection. Remember, in case of mirror, some of it was absorbed, right? Like whenever in case of mirror, when this reflection takes place, right? It is never 100%. Some of it is absorbed by the medium. But in case of prism, it is total internal reflection. Nothing is absorbed. So the image obtained will be of much higher quality when we are using prism. Understood? So this is used in deviation by 90 degrees used in periscope. Everybody knows what periscope is used for? Huh? No? So like ship, you have submarines underwater, right? So captains, what do they use? They use periscope. So there is some device which rises above the water, not the whole submarine, and then they can see enemy ship. So like this, because if the whole submarine is out, enemy can see you. But if it is a very small object which comes out, it's like a magic eye, right? Then you are underwater, but still you can see things above your height. That is what is periscope. So captain is seeing from here, from under the ship, and is able to see things much above his height. Okay. So we have 5 more minutes. I can cover the second application also, which is deviation by 180 degrees. So now you can see the diagram. I will not draw the diagram. Now see this diagram. Now it is again 90, 45 and 45. She is just waiting for 5 minutes to get over. Okay, open the book. This is the diagram, right? Now the incident ray is coming here. Again the incidence angle is 45 degree. Just figure out in the end. Second application.
Page 96.
My page number might be different. Okay. See this diagram. You tell the page number.
96.
Page number 96, first diagram. So the ray is incident. What is the angle of incidence? 45 degree by same logic. So it is totally internally reflected. Again here it is incident by 45 degree. Now it is coming out. So what is the angle between incident ray and the emergent ray? They are both opposite. Right? What is the angle between incident? So incident is in this direction and emergent is in this direction. So when you bring them together, what is the angle? 180 degrees. Correct? See, incident is going like this and emergent is coming out like this. What is the angle between both of them? 180. Okay? So where is it used? Huh? It is used in binocular and camera. Okay, just remember it. So binocular में क्या करोगे तुम? We'll use it like this. For one eye. So how is the ray? So distant object will come like this. Then here is your eye. Okay. This is how it is. So you are using reflecting prism so that you are able to see objects, distant object clearly. Okay, some various combinations. So these are the applications, right? And the last is you invert the image. See the last diagram. Okay. So here, Suppose the object is like this. After reflection, it is inverted. AB becomes BA. Okay? So, where is the total internal reflection happening? At the base. It is happening at the base. So, depending upon how the rays are entering, okay? So, here now there is refraction, and TIR at the bottom. Understood? When will the TIR happen? Whenever the angle of incidence is greater than critical angle. In this situation, it is not greater than critical angle. That is why it is refracted inside. Okay? But here it is TIR. So now the top ray becomes bottom and the bottom ray becomes top. So where is it used? It is used in slide projection. Because whenever the projected image is down, okay, you will invert it once again. So, pass the output through this and you will see the image upright. Got it? So I think we'll stop here today. Right? Not more time. So there are some more application of the prism. You can read. You can read yourself, and we'll end it in the next class. So how did you find today's class? Okay? Right. Alright, I'll see you in the next class.
तुम्हारा पास वारंटी है ऐसा तो बोल दो
वीडियो क्यों निकाला उसने मुझे पता
नहीं